All right, question 4 is going to ask you about an 800 square foot condo. And yes, for the second part of question 4A, I am getting a little tricky, but let's just start with the equation itself. So question 4, using a 4,500 degree day zone, how much energy would be lost in an 800 square foot condo with 9-inch fiberglass insulation at an R value of 19? So for this one, I have my home and I have my zoning. So my equation is going to be the sum of my 1 over the R value times the area times that by my 24 hours in a day times that by my degree days for the year. And so let's just plug that all in. So it's 1 over my insulation of R19, and that is an R value, so it is set up in feet squared, hours, degrees Fahrenheit, BTU, times that by the area of my 800 square foot condo, times that by my 24 hours in a day, and that is times my 4,500 degree day zoning, which is in degrees Fahrenheit of a day over a year. So now let's just plug that all in and get our answer to the first part. And right away I can take out my feet and my feet, my hours and my hours, my degrees Fahrenheit, and over here I can take out my days and my days. So I'm going to be BTUs in a year. All right, so when I plug that all in the calculator, the answer that I get is 4547368.421, and that is going to be in BTUs for the year. Now let's work on the second part, the A part to our equation of the question. I throw you for a curve and I tell you about the windows and the glass sliding door. And I tell you that there are 4 storm windows and a glass sliding door in this system. Now that means I need to sum up these as well as the house itself. And so I have to take the area of each window and set them up into a summed equation. So the windows, I have 4. All right, so for A, to find my 1Rs and areas and the sum of all of them, I have to write out each piece longhand. So I have my windows at 1 is going to be 1 divided by 4 times 1.74, and I'm going to divide that all into 1, and that's going to be times 12 feet squared. For my sliding door, I have my 1, which will be divided by the 174, and that's going to be times the 36 feet square for the sliding door. And then the area of the home, the condo, has to change, so it's the 1 over 19, but I have to subtract all those windows and doors from my area, and so when I subtract 48, I get 752, and that's my condo. So I'm going to do each piece of this and then add all 3 answers together. So do this, this is a number, and then add them. And that will give me this part of my units. And then I can go on to do 24 hours a day times my degree days. All right, so I find each piece and I add them together. And when I add them together, I get 62.012, and then I can times it by my 24 hours in a day times my 4,500 degree days, and so that's degrees Fahrenheit, day, year. That means my day and my day cross out, my Fahrenheit and my Fahrenheit cross out, and I'm left with BTUs in a year. And I put that in my calculator, and this is the answer I get in BTUs for the year. So I get 6,600,907 374.556 BTUs per year. And if you get something fairly close to that, but it's off by a little bit, it's probably because you rounded somewhere up here. And so I'll allow it to be off by a couple hundred BTUs. Remember, a BTU is a matchstick, so it's not much energy difference. Okay, so the last part is part B, which is going to ask me to now equate it for kilowatt hours at 75 cents a kilowatt hour. So I'm going to take my 6,697,374.556 BTUs in a year, and I have to change it to kilowatt hours, and I can look that up on my table, is 3,413 BTUs per kilowatt. That's going to give me my answer in kilowatts. So my answer in kilowatts is 1962.313. That's kilowatt hours. And now I want to know how much that's going to be for my 75 cents. So that's going to be times 75 cents. And that's going to give me my money amount. And so my change amount is 1,471.73. It's quite a bit of money rolling through. So it's probably not the most accurate question, but hey, I can't fault the book. You got to be there to know, right? So you're in a house, as long as we understand how we're putting together each piece. And so now let's move on and work on 5. All right, so for part 5, they're giving me a 2,000 square foot home, and it says family asked to do an initial energy audit for their 2,000 square foot home, and they live in a 7,000 degree day zoning, and the home has cellulose insulation with an R value of 28 in 4 walls, floor, and ceiling. What is the total energy lost for a year? So this is also going to be the degree day equation. So it's the sum of my 1 divided by the R value times by my area times by my 24 hours in a day times my degree day. And so let's just plug in our whole question. So it's 1 over my R's, and so I'm going to have the floor, the ceiling, and the 4 walls, and so that's going to be 6 times 28, because those are my R's, and that R value set, I'm going to make sure that it's 28, yep, it's 28, is in feet squared, hours, degrees Fahrenheit over BTUs. This is going to be times by the area of our 2,000 square foot home, times our 24 hours in the day, times my 7,000 degree day zoning, which is in degrees Fahrenheit, day, year. So let's take care of units. Hours and hours, feet squared, degrees Fahrenheit, and days, days. So I'm going to be left with BTUs per year. And so I'm going to set this up. 6 times it's 28 divided into 1. And when I plug all these numbers in, I get a nice clean number. Yep, right amount of zeros. And that's in BTUs per year. Now we're going to go on to answer the part A. So it says family has the option to buy alternative and standard electric energy at 8.75 million BTUs. How much would the loss of energy cost them? So if I have 2 million BTUs per year going through, and a million BTUs costs $8.75, I do 2 million divided by a million. That's going to give me millions of BTUs, easy math, so it's going to be 2 MBTUs for the year. And then I just take my 2 million BTUs and times that by my $8.75. And that allows me to get $17.50. So that's my energy loss and cost for the alternative energy. Now, the second part of the answer tells you that if you just opted for standard electricity without doing the alternative energy buy-in, it's $6.60 per million BTUs. So I do 2 times my $6.60 of my million BTUs, and I get my $13.20. And so this is your walkthrough, and this would be the amount that I would pay for regular. So this is regular, and this is my alternative plus my regular standard, and that would be my difference in the two costs. So one would be loss of energy at $17.50, and the other one would be $13.20. And remember, this whole unit is set up so that there's no windows in it. So it's a bit of a easy equation, and this wouldn't really be, once again, realistic numbers, but it's good to play with. I want you guys to keep in mind that I didn't go through question 2 on the worksheet because we had done it in class, but if you have any needs at all, please send me an email. I'm happy to answer any questions, and best of luck walking through and trying to do these problems.